702 and Cape Talk.
The Naked Scientist.
I can't remember the last time that I stood in on this show and got to speak to you, Chris. It has been a while. Good morning.
Hi, Kukeza. It's good to be back. How are you?
I'm good. Lots to talk about already. Some of the calls coming in, SMSs as well. The Naked Scientist is here, 021 446 0567 or 011 883 0702. Remember, SMSs as well on 31567 and 31702. Chris, before we get to, this is a very important issue of what was found by scientists in China, but a question that I have is the brain at birth a blank an empty space to be filled with knowledge, or is there already a stored memory which we then expand from there?
I'd say a bit of both, actually. If you think about it, there are some things we innately, and animals innately know how to do. You're not taught, for example, how to go to the toilet, or you're not taught how to cry, and you're not taught how to learn things. You just soak up information and you learn to speak by copying other people. You learn to do tying up your shoelaces by copying other people. So there are innate things that enable you to paint on that canvas, but the canvas is itself, yes, a blank sheet, which can be written and moulded. A certain extent of how good your brain is down to the genes that you inherit from your parents. They actually tell the brain how to wire itself together in the first place, so you have this blank canvas with some rules applied to it. And then the environment in which you grow up, whether you're an animal or a human, slightly more specialised kind of animal, the environment is really, really important. If you're not given a nurturing opportunity to learn and to have a rich life so that you can enrich your knowledge, then you won't continue to grow. And the brain is an incredible organ. It can acquire information, change its shape and structure. The brain you go to bed with tonight is not the brain that you woke up with this morning, because it will be remoulded and changed by its day's experience. And that goes on from the day you're born right through to the day you die.
Thanks for that. Naked Scientists with us. We'll take your calls in the next few minutes. But Chris, some scientists discovering hundreds of fossilized dinosaur eggs, some with preserved chicks still inside.
Yeah, this is an amazing piece of research, an amazing discovery by a group in Beijing. What this bunch have done, and they've published in the journal Science this week, is to describe a piece of limestone. It's a slab about 3.5 meters square that's turned up in northwestern China. And embedded in here are something like 200 or 300 eggs of pterosaurs. These are flying dinosaurs. They date from about 100 to 146 million years ago, the early Cretaceous period. And these are effectively birds' ancestors. But we didn't really know very much about these creatures, because in the last decades of studying them, researchers have only come across maybe 5 examples of eggs laid by these species with chicks inside. And it's important to see the developing dinosaur chick, because that tells you a lot about how developed it was when it was born, therefore what sort of environment it would have grown up in, and how dependent it would have been on, say, parental care or not, and also whether or not these things were likely to live on their own or to be part of a big group. Thankfully, this paper, which is by a lady called Zhaolin Wang, who's been working in this part of China for a long time, answers a lot of these questions. The assemblage of these 200 or 300 eggs, 42 of them still appear to have the developing dinosaur or pterosaur chick inside the egg. The team have been able to CT scan the block of sandstone, with the chicks in there, and then do very intricate anatomy on the chicks to work out how well developed different parts of them were. And the interesting fact that's emerged is that the limbs, the lower limbs, the leg bones of these developing pterosaurs are very well developed, even at this early stage in the egg, whereas the upper limb and the wings are very poorly developed. And what they interpret from this is that these pterosaur chicks would have been born and able to move around and hop about, but they wouldn't have been able to fly, and therefore they probably would have been quite dependent on another animal looking after them. The fact that there were so many eggs together argues, and at different developmental stages, argues that they lived in big groups. So this was like birds that form nests along a cliff. You get big groups of birds. We think that that's what these dinosaurs were doing. So they probably laid eggs on the shores of a muddy shoreline of a lake or something. They would have reared in a big colony, and the chicks would have been born fairly immature, not precocious and capable of going off on their own straight away. They would have been dependent on others to look after them. And the fact that we've got all these eggs is probably because there was a chance flood that washed loads of them into the water all at the same time, and then the eggs bobbed around for a while in a big raft, sank, buried, And here we are 100 million years later looking at them.
Wow. I've got a 10-year-old who's going to find this story very interesting. The Naked Scientist is here. We take your calls, your science-related questions. Kudar in Midrand, good morning.
Good morning. I'd like to ask, why is it that when someone makes a fart, people burst into laughter, yet the person who has done it feels embarrassed? I always find it interesting because if you watch most comedies, be it in America, UK, it's like the same thing. The person who does it feels embarrassed, yet everyone laughs.
Yeah, I think the reason for this is that we are terrified of drawing attention to ourselves when we don't want to. And it isn't just a fart. It could be falling over in the street or tripping or being made to feel foolish or, in your eyes, potentially being made to look foolish, because it makes people look at you and it makes people think that something that was out of your control happened to you. And that could be a sign of weakness, because if you let a fart slip when you didn't want to, then everyone thinks, oh, that person doesn't have very good control over themselves. And that means that it could display weakness. And, you know, as a competitive species, what we don't want to do is to display weakness, because people may regard weakness as something which could be crushed and overcome, because we're all in a fight for who's dominant in the world, in terms of our evolutionary origins, because the fittest survive. So I think probably it's a legacy of that. And everyone else laughs because actually it's a way of them gaining the upper superior hand, because they have got better control and better manners than the person who accidentally let one go.
All right, Kudar.
Right, thank you very much.
Kudar in Midrand. I was actually about to ask if Kudar has got an issue there, but let's focus on it being about what happens in comedies. Martha in Sharpeville.
Good morning. My question is, does eating raw garlic cause stomach cancer and stomach ulcers?
I'm not aware that garlic is linked to stomach cancer more than any other vegetable. Garlic is a member of the allium family. This includes spring onions and leeks, as well as the garlic family. And the reason they smell so strongly and so pungently is because they contain various sulfur compounds. These sulfur compounds are made by these plants in order to deter things from eating them, because they taste strong. We like that taste, but there are other things that like to eat plants that really don't like the taste, and it puts those things off. But they're intended to be a taste deterrent, not a poison. And there's not really any evidence linking eating these things to ill health. Quite the opposite. Eating fresh fruit and vegetables appears to be consistent with good health. So I think I can reassure you that eating some garlic is not going to do you any harm.
All right. Mark is in Centurion. Thank you for your patience.
Yeah, hi, good kids. Hi, Chris. Quick question. I mean, we're having a lot of thunderstorm at the moment, and we know that lightning is electrical discharge from one electrically charged pole to the other. I'm not quite sure whether the cloud is negative and the ground positive or vice versa. But I learned when I studied electrical engineering that the current will always find the path of least resistance. So therefore, I would like to know why lightning actually isn't bone arrow straight. Why does it appear to be jagged and going around five corners and even branch off? Why does it not just one straight lightning bolt that goes from the one charge pole to the other? Thanks very much.
Hello, Mark. Yes, so just to answer one of the other things you said you're unclear on, lightning comes from the cloud to the ground, and for reasons we don't completely understand, the cloud assembles a negative charge, and the negative charge pushes away the negative charges in the surface of the Earth because they can move, which leaves the surface of the Earth with a relative net positive charge. So the electric field between the cloud and the Earth is what we're talking about here, with a negative cloud, a positive ground, and the lightning is the path through the air by which that energy is dissipated. Now, the way in which this happens is that the air is a pretty good insulator. And the only way that lightning can pass between the cloud and the ground, in other words, the charged particles can flow out of the cloud to the ground and negate that electric field, is if the air becomes ionized. And ionized means you've got to break electrons free from particles and have free moving electrons that can be charge carriers. Now, when you actually have this very intense electric field, the lightning isn't coming out in just one strand that you see. There are lots of individual leakage currents coming off the cloud. And eventually, in the same way that a river forms a delta, a bit like the Nile Delta in Egypt, eventually you'll get lots of these strands will have formed, and one will become more dominant than the others, and the electricity will just take the path where there is the least resistance. In other words, there are the most ionized particles available to it, and that's the bright one that you'll see. And that will eclipse all the others. So there will be lots of paths down to the Earth, but there'll be one dominant one where most of the current goes down that route, and that's the one that you tend to see. It won't be a perfect straight line, just because in the same way that rivers don't go in a straight line, because they take the path of least resistance, the air isn't homogeneous. It hasn't got the same density with the same number of particles and all the same amount of ionization of those particles. It will have randomly ionized in various places and have more density of particles in some places, and as a result the lightning will pick its way where the electricity can flow most freely, and that won't necessarily be a straight line.
All right, makes sense to me. Tabang in Soweto, good morning.
Hi, this is Tawang. A quick question. I just want to know if there's a scientific explanation why other people are so quiet and others are very talkative. I'll listen on the radio.
A very important question there, considering we're in talk radio there, Chris. Any scientific reason why?
Well, we do know that, broadly speaking, the population break down into two types. There's extroverts and introverts. Extroverts are people who are outgoing. They don't mind being the centre of attention. They don't mind being noticed by other people, and they're very friendly and bubbly. There are introverts, and these individuals tend to shun attention. They are more, by and large, shy, and they tend to be interested in things which are pursuits that don't involve big groups of people. They might like to sit and read. They might like to play computer games, for example. It takes all types to make a world, and we don't know exactly why people fall into these two groups, but it's a good job that we do, really, isn't it? Because there are some tasks and some roles in the world where actually being an introvert who will sit down in a diligent way, exclude others and focus on a task to get it done, that's actually very beneficial over someone who is outgoing and bubbly and makes a lot of noise around themselves all the time. Imagine if everyone was like me. The world would not be a very sane place to live, would it?
702 and Cape Talk.
The Naked Scientist.
At 21 minutes past 10, we continue in conversation with the Naked Scientist, taking your calls as well. Tabo is in Santon. Your question for Chris.
Good morning to you, sir. Thanks for taking my call. I just need to find out. Astrophysicists talk about a concept of folding the universe to reduce the distance traveled between one point to another. What is that concept? How is it done?
Well, you're probably thinking of something. You're probably thinking of something called a wormhole. And the reason that scientists are venturing down this path is that it became pretty clear to us in the last few decades that the universe is absolutely massive. It's an expanding bubble, 13.8 billion years old, and it's growing, and the older it gets, the faster it grows. And the distances between us and, say, Pluto seem very big. It's about 6 billion kilometres to Pluto. So if I sent a radio message, if I was beaming this program to Pluto, the listeners on Pluto would not hear what I was saying for about 6 hours. So that would be a very, very drawn-out phone-in, wouldn't it? I say something, 6 hours later they hear it, 6 hours later I hear their reply. Very boring program. But that, believe it or not, is just our cosmic backyard. And if you then extrapolate this to the scale of a whole universe, the Andromeda Galaxy, which is the next door galaxy, is millions of light years away. It takes light millions of years to get to the next big cluster of stars adjacent to our cluster of stars, and that's just our next door neighbour. So pretty quickly it dawned on people who were thinking about how we might travel and conquer this universe that there's no way that we're going to be able to do it if we travel in conventional ways, because we know, because of what Einstein told us and many other physicists since, that the universe has a speed limit, and this is the speed of light. It's about 3 times 10 to the 8 metres per second, or 300,000 miles per second. 186,000 miles a second, 300,000 kilometres a second. And because we're governed by that, we can't go faster than that. It means that there are some places in the universe we could never hope to get to and never live long enough. So is there another way? And one theory is that you find a way of bending space so that instead of having to go A to B, you bend, like if you had a sheet of paper and the universe is that flat sheet of paper with A on one side and B on the other, you bend your sheet of paper to concertina it up. So your two hands, one with the thumb on A and the other side of the sheet is the thumb on B, your two hands move closer together. And instead of having to go right across the top of the sheet of paper, you effectively go A to B without having to go on this big loop of paper that forms between your two hands moving together. Now that's a theory, and as one theoretical physicist put it to me, you've got to be very cautious with theoretical physics because you can prove anything with maths that you like. Actually, whether it's practical, that's a different matter. And at the moment there are ways in which you can envisage that this might happen, but certainly the amount of energy it would take to warp space-time in this way, and that's where the whole idea of a warp drive that you see in programs like Star Trek, that's where it comes from. We don't know whether or not this will be feasible yet, but the theory stands up. And if you look, there have been various films about using big black holes and things that can bend space-time in this way, and perhaps that might be one way we can do it. We can find the ways in which big black holes have bent space-time in a convenient way, and this gives us a shortcut. But at the moment, it remains a pipe dream. Don't know about a wormhole.
All right, a couple of calls that I need to squeeze in the limited time that we have left. Mark is in Braamfontein. Very interesting question that you might have. Mark is gone. Shoes in Houghton.
Yes, I actually would like to ask, is space dark? And if that's the case, why? Because we get sunlight and darkness here on Earth.
Hi, Shoes.
On the radio.
Yeah, that's a very interesting point to raise. Why does space look dark when we've got stars in it? Well, our sun is a big source of energy. It's a big giant nuclear reactor which is beaming light at us. But the space between us and the sun is empty, or pretty much empty. There's probably about one atom in every cubic metre. And the reason something looks bright and light is because it is emitting energy at us. Well, if there's nothing in a patch of the universe and it's not emitting anything at us, then we're not actually going to see any light coming from that patch of the universe. And that's why you don't see patches of the space glowing, because sunlight is only visible to you when it is reflecting off a surface. So if you hold up a sheet of paper in front of you, it looks white. That's because light is hitting the paper and all of the different colours reflecting off the paper back at your eye so you can see it. If you're looking at a patch of space, there is nothing there to reflect the light at you, so the light waves, the photons, just come straight through and you just see darkness. Now, there's a slightly more subtle extension to this question, which is if there are 200 billion stars in the Milky Way, and there's about 200 million galaxies like the Milky Way, then there must be one followed by about 22 zeros, bright stars out there in the universe all over the sky. So why, when we look at the sky, does it not look completely white, like we've got suns everywhere? And there's a number of reasons for this, and probably the best way of thinking of this is that the universe has grown and expanded, and a lot of the light that would have been coming to us from those stars has been stretched out to become a different colour, so it's not white light anymore. That's one possibility. And also, these things are a very long way away, so the light's very spread out, so it doesn't all look white all the time.
An SMS that came in earlier, Chris, asking, please, can you explain the difference between dementia and Alzheimer's?
Well, they're both one and the same thing. Alzheimer's disease is one form of dementia, and dementia is where, usually with age, but it can happen in a young person too, you lose your cognitive faculties, and this occurs because something causes nerve cells to die or to go wrong in the brain. And there are a number of reasons why this may happen. There are a number of diseases that cause this to happen. Alzheimer's is the most common, and many of these diseases also tend to present clinically in a very similar way, and they get put under an umbrella of Alzheimer's disease. But Alzheimer's is one quite specific form of dementia, and it's where you lose brain cells because you have a build-up in the brain of a pathological or harmful protein, which is called beta amyloid. It's there in the brain naturally, but for some reason it starts to build up and form these blobs called Alzheimer plaques. And these we think are linked to killing off nerve cells, and it tends to do it in the parts of the brain where memories are first made and laid down, the hippocampus and that part of the brain. So if you lose that part of the brain, or you lose cells from that part of the brain, you tend to see the first symptoms of Alzheimer's disease being difficulty in remembering things, struggling with memory, and it then progresses to affect other aspects of a person's ability to function. But Alzheimer's is one of a family of dementing illnesses.
We're not going to have time to go through yet another call, and maybe we can squeeze one. If you are quick, Barris in Cape Town, very quickly.
Morning. Hi, Chris. Just a question. I've often watched the CD fan going round and round, and you can't see the blades. But every now and then, I can seem to focus on that one blade as if I've freeze-framed it. So I'm curious to see, is it your mind that does something, or does your eyesight somehow change that you can capture that blade individually for a short while? That's how I explained it correctly.
Just, I know we're short for time, but just explain that again at a slightly less frantic pace so I can get what you're saying.
The blades are turning. You can't really see them. They're just turning very fast. But sometimes if you just look hard enough, you can freeze frame that one blade while it's turning around for a short period of time.
Yes,
and then you've lost it again. So I'm curious, why is it? Is it your mind?
Yes, I think it almost certainly is. The way the brain works is it takes a series of snapshots of things and glues them all together, and there is a threshold frequency at which the visual system works. It can't go faster than a certain rate, and that's why TV screens are flashing on and off, say, 60 times a second, but you can't see that because your brain can't keep up, so you just see a steady image. Now, when you look at a moving object, there are parts of the retina, the light-sensitive sheet at the back of the eye, which have the ability to respond very rapidly to fast-moving things, but they're off to the periphery. So when you're focusing on something, you tend to see snapshots of things. If you look at something out of the side of your eye, you can perceive things changing more rapidly. So it may be that as your eye is scanning across the moving object, that the parts of the eye that actually see things moving very quickly and detect movement very well, they are informing your brain that this thing is moving and plotting the trajectory of the moving object, while the central part of the vision is giving you more detail about the thing that you think you're actually seeing, and the brain is stitching the whole lot together to give you the impression you're able to see one of the things that's moving very, very quickly.
Chris, we appreciate you. Thank you very much. I'll speak to you next week, Friday. Have a good weekend.
Thank you, Andrew, and thanks for the great questions, everybody. See you soon. Bye-bye.